Welcome to video 12.7 in our first Principles of Astrophotography series. In this video we discuss field rotation, which afflicts telescopes on altitude-azimuth mounts.
This video is based on section 12.7 of our first Principles of Astrophotography book, which is linked in the description below. I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensor sensibility.
This is a long exposure of the northern sky. The North Celestial Pole is right here at the center of all these concentric circles. This bright arc here is the North Star. We actually talked about this in a previous video, but the stars rotate about that pole, and that rotation causes problems on altitude-azimuth mounts. This isn't really to scale, but Cassiopeia, as we'll show in the next slide, is among these stars that are circumpolar from our latitude, from our 40-degree latitude. It's a kind of a W in the sky. When it's below the North Star, it looks like a W. And when it's above the North Star, it looks like an M. So here's when it's below the North Star, and here's where it's above. So if you have an altitude-azimuth mount, an altitude-azimuth mount has, yeah, that's it. Case in point. It can rotate in this direction, and then it can rotate in this direction. But it doesn't really rotate the field of view. It just, you can move around this way, then you can move up like this, but it's always going to take that picture in a rectangle like that. So when Cassiopeia is above the North Star, your frame is going to see an M. And when Cassiopeia is below the North Star, it's going to see a W. Right. And so the pictures that you're getting are constantly shifting. So let's read the concept.
Field rotation is the rotation of objects in the field of view on an altitude-azimuth mount. Field rotation does not occur on polar-aligned equatorial mounts. So
the C-Star now supports polar aligned equatorial mounts. That's awesome. We haven't tried it out, but it's a lot of people are having a great experience.
We've equatorial mounted. We just haven't done it with their software.
We rednecked it back in the day before they actually support it. Yeah. And so we have done that. That's right. But
I remember looking in the forums too when we had the C-Star, and people were like, "Why am I getting all of this fuzziness around the edges, and the center is nice, but everything else is yuck?"
Yeah, it's a little hard to understand, and people say, "Oh, it's field rotation." Well, what's that? So here's an example of field rotation that we did of NGC 4565, aka the Needle Galaxy. So these are two frames that we took using this very C-Star of that object at two different times of night. Well, the galaxy clearly has rotated within the field of view, and the reason is we're using the C-Star on an altitude-azimuth mount. And what happens when you stack these images? So that was one of the questions that we had when I got started in this business is, well, will the stacking software actually both move the objects and align them in the X and Y direction as well as rotate them until they match each other? The answer is yes, it does both. So when you stack a sequence of exposures that you've taken with the C-Star, either you can stack them in the C-Star, you can stack them in PixInsight if you save the individual exposures. It will line them up, move in the X and Y direction, and rotate them until they match up. And so what you get is a stack that looks like this. This is an actual stack produced by the C-Star. But notice what you end up with. Everything overlaps just fine and everything matches, all the stars match up. But you get these wedge-shaped things in the corners. And the reason is it's taking, in some of the exposures, you didn't get those stars in those corners. In other exposures, you did.
And in some exposures, the background was brighter. In others, it wasn't.
Yeah. So it can be a pain. I don't know if you remember, we probably processed this 2 years ago or pushing 2 years ago. But it can be a pain to, so it basically looks like a gradient in there, right? That you have to try and remove. Yeah. So you can either just crop it in and say, to heck with it, I'm not worrying about all those ugly corners, or you have to try and get rid of them, and somehow you did a pretty good job. This is
PixInsight does a better job of stacking than the internal C-Star software does. Yeah.
Well, you still get the wedges in PixInsight or no?
Yeah.
Yeah, but somehow you're able to finesse that bad boy out of there, and but anyway, with equatorial mounts, where you're polar aligned, either the north celestial pole or south celestial pole, you don't get that field rotation. So the price you pay for an equatorial mount, you have to polar align. Mm-hmm. You have to get yourself aligned with the North Star, at least approximately so. And we used to use a laser pointer, and we've done different things with the C-Star.
Yeah.
And of course, if you have an ASI Air and a dedicated astrophotography rig, the software is just so amazing. It takes a picture, and then it tells you what direction you need to move the mount to make it point, and it takes a couple of minutes in some cases, 5 minutes in other cases.
That's so awesome.
It's so fast.
But essentially what you're doing is you're taking your telescope, your whole bottom of the mount, and you're pointing it at the north celestial pole.
That's right. That's right. And so the price you pay for avoiding field rotation is polar alignment. We think it's a price worth paying just because post-processing is so much easier and the images turn out better. Plus, you can't really take exposures more than 10, 20, 30 seconds long on an alt-az mount.
No.
Why? Because it's rotating while you're taking the exposure, and that's really super embarrassing. You're going to get a little star streak. If you took a 5-minute exposure on that mount, but with an equatorial mount, you can take 5-minute, 10-minute exposures as long as you want. Because
well, and the C-Star is trying to guide. It's tracking. It's tracking. It's not guiding. Yeah, but it's trying to kind of match as best it can how the sky is rotating, but it can't.
It can't rotate.
It can't rotate that direction. Yeah.
Yeah. Thanks so much for watching.
And we'll see you next time.